When we were researching the 1066 landscape at Fulford, we encountered quite a lot of charcoal, but in one place we were actually able to plot what appeared to be one pit. We wondered whether this might be a burial place. We wondered if it could indeed be a natural burning situation that we were encountering where we got annual burning. But the colours of the clay layers above it told us that this had been a man-dug hole. Now, although traditional charcoal making involves building a large surface pit, building a great mound of charcoal, these are still called pits. This led to some speculation that we might indeed have places where charcoal was being made. But it was not until a visit to Scandinavia where we actually discovered that this was the method used by people in that area around the time of the battle. At about the same time, we also realized that we had 3 smithing hearths, and so the possibility that these very nearby charcoal making areas were in fact related. But there was a small problem. Stamford Bridge, we know, happened just 5 days after the Battle of Fulford, so we know that any charcoal making would have had to be completed by then. So the question arose, could we actually make charcoal pits and produce charcoal in this tight timetable? The answer was to do some experimental archaeology. We started by plotting out the size of the hole that we had found using an auger, and then we found a suitable place where we could actually dig a hole. Happily, there was lots of wood available. Quite a lot of it was reasonable stuff, pine wood, but there was also quite a lot of sycamore that we had to use. One of the keys to making charcoal is to make sure that the wood is very tightly packed. So the wood was carefully cut to the right lengths, and an assorted range of thicknesses were prepared so that we really could pack it nice and tightly together. The other important part of the construction was to make sure that there was a chimney up which the air, the smoke, could circulate. This is vital to get a really good burn. Because the pattern we had worked out from the augering of the pit that we had found seemed to have like a ramp built into it, that is what we did with the hole that we dug. And this proved very useful when it came to lighting, because it was possible to push a fire right into the heart of the blaze when the time came to light up. Once it was all well going, cover it over with leaves and bracken. This was necessary to stop the soil that we were then going to dump all over it from falling into the fire and putting out our lovely fire that we just got going. Keeping it covered was a full-time job. The fire had a great tendency to seek out and burn holes through the soil that we had put on top of it. Sadly, practicalities like having to look after children and go to work prevented being able to watch the thing through the night and all through the day. So from time to time, the fire did manage to break through, and therefore we did lose a certain amount of potential charcoal. So what's happening inside with this fire? Wood is made up of water, then there are various volatile hydrocarbons, plus of course the lignum, which is the material of the wood itself. When the heat gets going, first of all it blows off the water and you can feel the steam and see this very light coloured material blowing away. Then the light volatiles come out. Then the tars and the hard stuff, the wood itself, starts to turn into carbon. What we have to do through the fire is to keep the fire hot enough, blow off all of the oxygen and all of the hydrogen, so that all we're left with is something near pure carbon. To do this, the key is to keep the heat up, and to do that it's necessary to get the right supply of oxygen going into the fire. By happy chance, the amount of air that seemed to filter in through the covering was just about right to keep a nice steady flow of smoke rising, particularly from the chimney, which was gradually closed down during the first 24 hours of the burning. The entrance ramp, where we'd lit the fire and where we hoped to extract the charcoal, of course had to be very thoroughly blocked, and it presented quite a problem as it kept collapsing and air kept rushing in there, so that we were having a bonfire rather than a charcoal pit. Although we made our pit round, subsequent studies, and there's been a great deal more archaeological work since the time of this experiment, have revealed that most of the pits were in fact square in shape, and none of them have got convincing evidence of ramps. However, the ramp proved invaluable both for getting the fire lit and for extracting the charcoal at a later date. So what did we discover? We were, on the very first day that we lit the fire, we were that night able to start extracting charcoal from the core of the fire itself. The charcoaling process had worked really well at the center and was obviously then working its way out through the other layers. There is of course some danger when you start to extract the charcoal. First, air gets in and gets the fire going a little more strongly, but also the charcoal that you're extracting is itself very hot, and if you're not very careful you'll find it will burn. So you do need to have some water to hand so that you can douse it right down and cool it. But in the environment where we think this might have been being used, with the smithing work going on nearby, they could very well have been very happy that this stuff was already alight and could simply be taken to the smithing hearths and put straight in. So this bit of experimental archaeology demonstrated that it was possible to make charcoal very quickly and to start extracting it very promptly. The whole thing was burnt down and could have been available for use well within the timescale set by the destruction of the Norse invaders at Stamford Bridge 5 days after the Battle of Fulford. Now that we've done the experiment, of course, it would be very nice to go back and actually excavate this area where we found not just one pit, but in fact we think we found 3 different pits, possibly each one associated with a different smithing hearth. But sadly, so far, access to this has been denied. Those who took part in the experiment can vouch for the high quality of the charcoal produced, which provided several years' supply of excellent barbecue fuel.